Assalamualaikum to my fellow panelists. My name is Muhammad HANIFF bin RAMELI. I am a semester 8 student in Bachelor Mechanical Engineering in UiTM Shah Alam. I am currently being supervised by TS Muhammad Fauzi bin Osman and Prof Madya Dr. Juri Saidon. I will present my final year project, which is the influence of process input parameters on axial cutting force during ultrasonic assisted milling of borosilicate glass through ductile mode and brittle mode mechanism. This is the content of my presentation that I will explain later on. First, I will go through the project background. In modern days, most technology applications use borosilicate glass in the industry such as biomedical device, optical lens, aerospace and others. Borosilicate glass has high durability and resistance to the chemical chain. However, the mechanical properties of borosilicate glass make it difficult to manufacture, especially when using conventional machine. Through experiment and research, it is said that a non-conventional machine is a proper solution to tackle hard and brittle material. Ultrasonic-assisted milling operates by combining the milling kinematic with the grinding material removal mechanism with the ultrasonic assistant that enable it to vibrate vertically along its z-axis. In this project, the mathematical model is proposed into two different material removal mechanisms, which are ductile mode and brittle mode. These two mechanisms will directly affect the final material removed volume for the brittle material. For the literature review, I will focus on past research paper about ductile and brittle mode. For ductile mechanism, a paper published by BKA Ngoy and PS Rejit in the year 2000, they said that ductile regime grinding can become plastically deformation if the size is too small. However, in this study, there is no mathematical model to prove the ductile mechanism. In 2018, AKM Nurul Amin and her team studied two distinct methods of material removal, which are ductile and brittle. Then, in 2019, Y.L. and H.L. Hofi finalized the mathematical model related to the Hertzian indentation theory and used it on soda lime glass for ductile mechanism. The concept of Hertzian indentation theory can calculate the indentation depth into the surface within specific range is generated from the equation published by Timoshenko and Godier in 1970. Next, for brittle mechanism, the material removal will form lateral cracks and median cracks as shown in the figure. It is said that these cracks act as sharp indenter to remove material studied by Ostojic and P. McPherson in the year 1987. But the mathematical model also not investigated in this study. Then, Y.L. Tabani and H.L. Hofi used viscous hardness theory for brittle mechanism using soda lime glass derived from the equation introduced by B. Lon and R. Wilshaw. Hardness H as deformation parameter showing medium crack development. Toughness K as fracture parameter used to evaluate strength level in the material. Detailed explanation on both theories will do in methodology. There are two objectives of this study. First is to perform mathematical modeling to investigate the influence of process input parameters on axial cutting force in ductile mode and brittle mode. Second is to predict the value of axial cutting force for both mechanisms without doing actual experiment. This result obtained will be verified with past research papers to validate the experiment. Next, I move to the problem statement. Borosilicate glass is desirable material because it has many uses in the industry nowadays, but it is a material that difficult to manufacture when using conventional machine because it is easy to fracture. Hence, how to predict the value of axial cutting force on borosilicate glass by using non-conventional machine and different input parameters. This purpose is to ensure the high quality surface product can be obtained and increase higher productivity. For scope of this project involve literature review on past research paper to collect information and for mathematical model verification. Next, understanding mathematical model development for ductile mode and brittle mode mechanism to predict the axial cutting force. Then, develop the coding for mathematical modeling formula into MATLAB software to get the result. For the limitation, this project cannot do actual experiment because the high cost for machine and material. Safety factor also considered because of pandemic COVID-19. Next is methodology. This is the full flowchart process of mathematical model development that I will be explaining briefly in the 4 main steps. Step 1 is to understand the relationship between single grain force and the grain indentation depth. This is where the ductile plastic deformation of Hertzian indentation theory is applied to the ductile model. The equation of the indentation depth is simplified in terms of contact force. Viscous hardness theory is used to brittle model and also is simplified in terms of contact force. Step 2 is to understand the relationship between UAM cutting force and single grain force. So, left image on the slide shows the number of grain face and the number of grain side equation. Equation for grain side including depth of cut. Both equation will be multiplied by 0.45 assuming abrasive active grain. The modeling equation for effective cutting time is done based on sign graph and simplified into the final equation as shown in the figure. Step 3 is to estimate the actual volume of material removed by 1 grain's indentation depth U and calculate material removed volume W from the relationship between input variables and material rate removal MRR. As for the ductile model, the indentation volume U of diamond grain penetrating into the workpiece is the intersection between intended spherical grain and the workpiece will be a part of the ellipsoid. So, indentation volume is calculated by the integration as shown in step 1. While the equation of removed volume W that relate to the feed rate and depth of cut will be obtained from the equation of MRR by simplified in terms of W. Step 3 is equaling equation U and W. Lastly, simplified in terms of indentation depth delta, the equation is obtained as in step 4. For the brittle model, according to the sharp indentation theory as shown in the figure, the equation of lateral cracks and head of cracks, where KLC is the fracture toughness and HV is the workpiece hardness. The indentation volume U for brittle fracture is simplified 2 times the volume of tetrahedron ABCD as shown in the figure. By equaling the equation U and W, the final equation for indentation depth for brittle model is obtained as in step 4. The final step is obtaining the UAM model cutting force, where you can see is the multiplication of contact force Fn, number of grain face, effective cutting time, and vibration frequency for both ductile and brittle mechanism. This is the basic coding using MATLAB software to get the results for the ductile mode and brittle mode. Next is results and discussion. For case spindle speed vs axial cutting force, when the spindle speed increase, the axial cutting force will decrease for both mechanisms. It is because cutting force are reduced when the chip thickness is decreased. Next, for the feed rate case, as the feed rate increase, the axial cutting force also increase for both mechanisms. This happens because when the machining loading increase and the relative cutting arc length of each abrasive grain grows longer, hence the cutting force increase. As for the depth of cut, when the depth of cut increase, the axial cutting force also increase. This happens because the amount of material removed, which in turn increase the cutting force required to remove the material. All the 3 models are compared with the soda line glass result to verify the data. As seen in all the models, the ductile mode produces higher cutting force compared to brittle mode. The specific cutting energy increases as the indentation depth grows in the ductile mode. However, in the brittle mode, the cracks initiate, propagate, and intersect, resulting in a loss of material strength, hence reduce the axial cutting force when compared to the ductile mode. Next is verification with the actual experiment. Even the actual experiment is done on soda line glass, it still can be referred to the borosilicate glass case because both glasses show the same pattern results. The red line show the actual result of experiment on soda line glass. It shows the transition of phase between two mechanisms. Ductile mode happen at lower feed rate and brittle mode happen at higher feed rate. The actual experiment also gave the same result. This also applied to the depth of cut case. Next is the conclusion. All the objectives in this experiment were achieved. The pattern of the results are comparable with the research paper and the actual experiment. The predict value for ductile mode happen at low feed rate and depth of cut. In the brittle mode, the predict value happen at high feed rate and depth of cut. Further studies can be done on ceramic or fiber by considering these two removal modes. Instead of axial cutting force, the experiment can be done to analyze the tool wear or temperature rise by using this model. Lastly is the project originality. This study focused on axial cutting force using borosilicate glass that has never been investigated yet. In addition, the experiment being conducted refer to the mathematical models and past research papers without doing actual experiment. I think that is all from me, and thank you for your attention. Please contact me, refer to the contact information given if have any question regarding this project. Thank you.